Okay, exercise 2, they tell me to know if the vectors that I'm given have the same direction or not. So to do it, you only have to write vector u, which is 3 minus 1, and vector v, which is minus 3, 1, and do what I've told you before. Compare the components, like 3 divided by minus 3. Is it the same as minus 1 divided by 1? In both cases, what I get is minus 1 equals minus 1. So yeah, they have the same direction. B is the vector u now is 2 minus 4, and vector v is 1, 2. I do the same thing. I compare them. Here I have 2 divided by 1. Is it the same as minus 4 divided by 2? And the answer is no, because they are the same value, but not the same sign. So answer is not. Exercise C, it's u now is minus 2, 0, and v is 4, 0. Do they have the same direction? Okay, to do it, what's interesting to do is in this case, because I get minus 2 divided by 4 is the same as 0 divided by 0. Can I calculate this? It's a bit weird, isn't it? So to do this, it could be useful just to draw it, because minus 2, 0, it is like something like this. This is vector u, and 4, 0, it's the same, but the other orientation. So even if this is not absolutely true when we have a 0, what we can assure is that they do have the same direction, because one is the opposite to the other. When we have zeros, it always happens the same thing. They will always be, if I only have the same component, they will always be proportional, so they will be in the same direction. D is vector u, it is 5, 2, and V, it is 2.51. So I do the same thing. I divide this by this and this into this. And what I get is this is 2 and this is 2, so they have the same direction. Next example, it is minus 2, 6. B, it is minus 3, 1, and I can perfectly see that they won't have the same direction. Here I have minus 2 divided by minus 3, that's 2/3. It can't be equal to 6. And in this other case, here, it is 0, minus 1, and here I have v like minus 2, 0. If I do this, of course, when I have zeros, it's difficult to compare because you can't really know. It's difficult to know. But at the same time, if I do the pictures I've done before, 0 minus 1 would be 0x minus 1 here. So this is u. And v, it's minus 2, 0. So in this case, it's impossible that they have the same direction because the 0 is not in the same place. Okay, I hope you understand it better, but if not, you could be able to ask me when I'm in class. Exercise 3, it's about linear combinations, and it says that we have 3 vectors, u minus 3 minus 5, 8, v minus 41 minus 10, w 3, 6, and what I'm asked in first exercise, which is A, is to write the vector that will be the result of calculating 3 times u minus 2 times v plus 10 times w. Okay, if I do this, what I have to do is just to do the calculations here. I have to multiply the vector by its numbers, and then I add them or subtract them, whatever I have to do. If I have to do 3 times u, that would be minus 15, and then 24. If I have to do minus 2 multiplying v, if I pay a bit of attention here, I have 1 minus, and here a minus as well. So I could turn this into a positive 1, taking into account that I have to change all the signs in here. You can see that, it's no problem if you don't do it like that, because you will get to the same value. That would be 82, and that's 20. And if I multiply 10 times w, you get 30 and 60. So when you add them all, what you get is a number which is 97,104. And that's my linear combination. That's the answer. Then in B, what I'm asked is to express this V as a linear combination of U and W. Okay, I want to put them together to get V expressed as a linear combination of these two vectors. Okay, to do that, what I do is, okay, I plan the system as I've done before. V has to be something multiplied by U plus something multiplied by V. Okay, how do I do this? Well, I think in your book it's X and Y, but it's a bit confusing, I think, because I prefer to write it like A and B because X is always the first component, Y is the second, and you can get it a bit wrong. So I think you might understand it better this way. What you have to do is you write here minus 41 minus 10. Here you write A multiplied U, which would be like this, and B multiplied V, V multiplied W, sorry, that is 3, 6. So what you get is you get to plan an equation, a system of equations, because it's this minus 41 equals this and this. So that first equation would be minus 41 equals minus 5a plus 3b. This other equation here, if you do the same thing, you get this, but then you get the y component and the y component. So you get minus 10 equals 8a plus 6b. It's easy to solve this if you multiply this by minus 2 because using reduction method, you get it very easily. And the answer to this is x equals, well, you can solve it. I mean, it's easy. Not x because I wrote it with a and b, sorry. It is a equals 4 and b equals 7. So if I want to express W as a linear combination, what I should do is V equals 4 times U plus 7 times W. And that's the answer to B. And that's all by now. That's the first video. It ends here.